In this video, I wanted to share with you guys how to create a twist cap twist. So there's a few, I've gone through a few iterations as to how to create a successful cap for something like 3D printing. And I've come up with something like this. So I've been working on the script and I've got a lot of stuff going on here, but I want to go over creating the basics of this. So if we go here, let me move around a little bit. So this is the object that is twisted around, right? So there's a polyline that's twisted all the way around. And I basically swept this polygon around. So that's the basics of it. Now I did have to cut off the top and the bottom of this one so it doesn't start, so basically it transitions from like from smooth and starts creating the twist. So that was kind of the difficult part. Now I have been able to successfully print a few prototypes and they work really well. So I'll share with you how to create a cap, and that cap can be used for many things, from connections to creating containers to creating like nuts and bolts and things like that. So I'll go over those steps right now, but I wanted to share with you this one. And also when you offset, let's see here, so, and I'll show you the cap, what it looks like at the end. So this, I'll bake it. I'll take this to the side and show you that when I do a clipping plane, let's go here into Rhino mode and I'll do a clipping plane and do vertical and just pick the quad and do a vertical cut. You'll see that it also has the twist. And what's interesting is that the twist has to have a tolerance offset, so it's able to open and close. So that's what I made sure to have for this. I'll also share with you how to do that. So let's jump into how to create it. So in this video I wanted to share, let's show you. This was a container that I made for my daughter. And it's using that same technique of creating the twist, which starts super subtle there, as you can see, and increases, and then at the end it does the same thing. So this was another prototype that I made, and for the cap, it closed really easily. There's no issues. Also, I created this textured kind of knurly for the closed cap. So then she put a sticker on top. So it's really cool. It's actually closes down perfectly. It doesn't have any issues. And with, you know, you close it with some force, you can open it up. So just wanted to share with you guys some of that prototype, and I'll be going over on the next video how to create the cap that has a little bit of a tolerance. Yep. So first things first, let's go to units and make sure that we're working with millimeters, because that's what a 3D printer would use. So millimeters, that's fine. And I'll go here to a new file. So when we do a twist cap, the geometry is going to be a circle. That way you're able to rotate it around. So first thing, we'll bring in a point. So I'll go to construct. Construct point. And I'll put that into a point component. Next thing, we'll bring in a circle. And that'll give us a guideline as to how big the cap is going to be. So I'll plug in into this point, into basically into the circle input of plane. We'll plug in the circle now. it might actually even be a better idea to type in X, Y plane and plug in the XY plane, which is a ground plane or a plane that's here. And that'll be kind of where it springs from. Now we can move that using set 1 point. So with this, let's go ahead and give it a radius. So I'll just say 30. So this will be the cap size, right? So I'll go here. Cap size. Now notice that 30 is actually the radius, so the diameter is going to be 60. So for the cap size, I actually like to use the diameter because that's going to be kind of the biggest size. Sometimes if I use the radius, I'll end up making things bigger because you think the radius is the biggest size. So what I like to do is just do division. Do divide by 2. So we'll do 30 divided by 2. That'll give us 15, and we'll use that as a radius. So it'll give us a diameter of 30. Now I'll take this point and we'll move it to the right here. So I'll go to move and take that initial point, move it in the X direction. So I'll double click here and go to X. And I'll plug in the X vector into the motion and then plug in this value, which is the 30 divided by 15, or divided by 2. Now with this one, move this down. Let's go ahead and take this and move it vertically. So this will be the height of the cap. So we'll take that point, move it vertically. So I'll do motion here, Z. And I'll give it a value. I'll say 15. So this is going to be cap height. So we'll take this one, and we'll do a line to bring them together. So we'll do this start point and this as the end point. Oh, this is the end point. And I'll group these so I can just keep it organized from the beginning. So as you can see, now we have this line. This line, we're actually going to divide it. We'll go to divide curve. We'll plug in that line into the curve input, and for the count, we can just say 20. Now, the more points you have, the higher quality the curve is going to be, or the interpolated curve is going to be. But once you add, more than 10 or 20, then you're probably good. Now with these, what we're going to do now is we're going to take these and we're going to rotate them relative to this center point. Now the center point that we're going to use is going to be the initial point, and we're going to rotate each one of these points an interval of 5. So it'll be 5, it'll rotate this 5, 10, 15, 20, 25, all the way around, or whatever value we can plug in. So for that, we'll go to rotate. And I like to use the component called series to create the incremental steps. So for the angle, I'll right click on the angle and go to degrees. For the plane, that's going to be the location of where you're rotating it from. So we'll plug in our origin plane, XY, and we'll plug that into the location of where it's going to rotate from. Next, the geometry. We're going to rotate those points. And as you can see, automatically we have 0.5 pi, which just means that it's going to rotate all of them, but it does all of them at once. So what we want to do is rotate them using degrees. rather than radians, and we'll bring in an increment of rotations. So for that, we'll bring in a series component, and the series component, as you can see, gives us 10 points, or 10 values automatically. Now we don't want only 10 values, we actually want 20. And the step is going to be how much we're going to step by the angle. So we said 5. So I'll go to 5 here. And I'll change this to rotation step. And so the rotation step goes into how much it's going to step by. And as you can see, now we have 20 values starting at 0 and stepping up 5. So we have 20 values stepping up 5 every time. So let's plug that into the angle. And as you can see, they all rotated, but at the end, there was one that didn't rotate. That means that we actually have to not have 20 count here, but we need to have one more than 20. So for that, I'll double click here and go to plus 1. That'll give me a addition component with the input being empty and b being 1. So I'll do 20 plus 1, plug that into the count, and that'll fix that issue of the last one. So you're just adding one more to the end, because as you saw, when you put 20, it's missing one value at the end. So that's just one way to fix that. And now we can change the step amount. So let's go to range, give it a max of 50, hit OK. And what we can do is just increase the number of subdivisions to create more and more twists. And the rotation will take care of the amount. Now, if we wanted to, we could figure out the step depending on the number. So with this, we can actually, it's a little bit hard to know to get these exactly starting and ending in the same location. So for that, we can do a quick mathematical equation that will help us keep things organized, and you'll see what I mean. So what we'll do is, rather than doing a rotation step, what we'll do is we'll do a division. And we know that we have 48. So we'll bring in a panel, first of all. And we'll plug in a number 360, right? Because 360 is the number of degrees in an angle. So we'll do that for A. And since we're dividing it by 48, we'll plug that into B. And that'll give us 7.5, which if I do plug in 7.5 into the step, it will actually create one perfect rotation from beginning to end. Now, if I want to, I can actually multiply. I can create not just one rotation, I can create multiple rotations. And for that, I'll bring in a multiplication. And I can multiply this number that comes out for the count, or for the step, right here, 7.5. We'll plug that into A, and for B, we'll just say 2.5, and we can plug that into B, and use the fact, basically this is a multiplication factor. Plug that into the step, and you'll see that now, if I say 2, it creates 2 complete twists from beginning to end. If I do 3, it'll create 3 twists from beginning to end. So this is a very useful way to keep your twist and number of twists that you're going to have here organized and clean, rather than having to pick a specific angle. So hopefully that makes sense. If it doesn't, it does. I have been working on this for a while, so some of those things will take a little bit of practice, but if it does make sense, then good. So let's move over here. Next is taking these points and we're going to connect them using a polyline. So I'll go here to polyline, and actually it's not going to be a polyline, it's going to be an interpolated curve. And so we'll plug in the geometry into the vertices, and that's going to be our twist. Now we can increase the number of points, and that's going to make our curve better. Like the smaller the points, the curve is going to actually have issues at the beginning and at the end. And you can see that in top view. So the more points you have, you see here that we have less issues, right? So I'll go to like 100, and it doesn't really matter because points are really light on the computer, and all we're going to do is just create a line that goes through that. So even if you go up to like 100 points, you should be good. So I'll take all of this stuff and let's just hide it, because we don't need anything except for this twist. Now I do want to make sure I have this organized. So I'll call this number of points. This is going to be, let me delete this, and this is going to be number of twists. And it doesn't have to be an even number, it can be 2.5, and you can get one starting here, and one ending there. You do 2.75, so we can go even further down in the digits for our numbers here. And let's group it together. So if I do 2.75, you see that it does 2.75. But let's keep it at 3. Now the next step is going to be to create the object that goes all the way around. Now I've tried using pipes, I've tried different ways, and I think my favorite way so far of doing it has been using a polygon and using a triangle specifically. So I'll give you, let's show this here. I'll take this one and I'll bring in a, first what we're going to need is to create a plane where we can create our polygon, because right now if we bring in a polygon here, it's going to be on the ground. So what we'll do is we'll bring in endpoints of this curve, and we're going to take the starting point, and that's where we're going to locate a, let's see, this would be an XZ plane. And as you can see, it puts it in the origin. We want it here, so we'll go to the start point and place that there. Now what we want to do is place a polygon here. So I'll double click here and go to polygon, and we'll use this plane as our origin point for this geometry. Now, like I told you, what I like is to have a triangle here, and that's the one that worked best for me. So I'll do 3 and then less than, 10. That way we start at 3, end at 10. Let me actually, but we'll keep it at 3 for now. So we'll use 3 as the segments. Radius is going to be the size of it, so that's important to have some decimal points. So I'll do 1.500. It's going to be twist size, and this is going to be twist shape. So twist size is going to be on the radius, twist shape. And fillet radius is also one that I use. So I'll use this one, copy it over, and change the name to fillet. To organize this, I'll use the little arrows, clean this up a little bit. And we can even create a circle, right? So the bigger the fillet that we create, we can end up with a circle. But I like to just have it a little bit rounded off. It helps when you create kind of straight edges like this for 3D printing. It gives us a little bit of issues. So I like to sometimes fillet it a little bit, even like 0.2 something or 0.3, which is it's not much really. What we can do is increase the twist size. Just do like 2.5. And we want it to be less than halfway between both of those. So let's actually decrease that. So now that we're here, let's take these, disable preview. Now, I initially, when I first did this, I was like, oh, okay, this is gonna be simple. If I do a sweep 1, and I take this curve, this rail for, yeah, that one for the rail, and this one for the sections, it would work. But notice that it actually won't work. It'll start twisting it, and at the end, the polygon is located in the wrong location. And if you change the miters here to all the different ones, it doesn't work. So what I had to do was take this and bring in a move component, and I'll just plug in this one here, and automatically it's actually going to move it vertically. So you can use a smaller number. For me, I just leave this one. And what we're going to do is do a sweep 2 using this as our second rail, which it doesn't matter that it's up there, and this one as our first rail. Now we'll hide this one, and notice that now for some reason, and I think it's because of the reference, it maintains the reference directions. Let's go here to sections. Notice that now it works. So this is really useful because now we can see here. You can even change the shape, which I wouldn't suggest. I think 3 is one that's useful. And the reason why it's useful is because it also intersects with the solid. So let's go here. So as you can see, that's going to be the jump off point for creating the twist. So the next step is going to be to take this and put it, bake it into solid. So for this next part, I'll keep it a little bit simple in the sense that we'll just take this and we'll join this with a form to create kind of the inside portion of the cap. So let's go here to our initial geometry, which is our circle. Now, we actually haven't used our circle at all, and it was one of the first things that we did, but that gives us an idea of kind of the location and the size of our cap. Now what I'll do is I'll actually just extrude this up to create a solid. So I'll take the circle, and what I like to do before I extrude it is I like to turn this circle into a boundary surface. That way when I extrude it, it'll actually extrude into a solid. So I'll take the surface and do an extrude. And I'll take the surface, plug it into the base. And for the direction, we'll do the cap height. Right? So now if I were to take this and already put it together, use a solid union component. Excuse me. I'll hold down shift and plug in to the B-reps here. and I'll flatten it. So I'll show you. Oh, and it actually didn't work. And the reason for that is because this is not a solid. This is actually just a swept around surface. So we'll actually need to turn that into a solid by going to bring in a cap holes component, and that's what we'll actually use. So holding down Control, I can unplug, and holding down Shift, I can plug in an additional component, and now this will work. But the reason why I wanted to do this before we move forward is to show you that it actually is not, this is not a good cap, because we have this overhanging here at the top, and we would want it to start right here. So that is the reason why I actually like to, let's bring this back, and let's bring this back, and I'll group those together so I know. Now to delete the top and bottom part, we're going to use, we're going to extrude from the top down a solid. And for this one, we'll do this, we'll just mirror that object and do the same thing to the bottom. So let's actually take care of that. So let's go to a box component. And a box component I like because it'll create that bounding box around that solid. And what we want to pick is that top surface. So we'll deconstruct the burep and pick the top face. So we'll go to a list item, which is a component that will let us pick one of the items. So right now we have 6 faces, and with this one, it lets us pick just one of the faces. Now, what I like to do is, if the one that I picked was not the correct one, which is the side, sometimes if I reverse the order, it gives me the one that I want. So I'll use that one, and I'll disable the preview and disable the preview on all of that. Now what I want to do is to extrude this down. So we'll take this and go to extrude, and we'll take this item and direction. We're going to go Z, and we're actually going to go in the negative, right? We want to extrude this down. So we'll do and we'll plug in a value, we'll say 1.5. Now 1.5 is the correct number, but let's say and that's because I was kind of using that as the radius value. But let's say you didn't want to use a slider to cut that off. You can just use the radius size. So if you use the radius size, plug that into the factor. And we can add a little bit more. So we can do 2 twist size, and we do times 2, which will be the diameter of it. And it's actually doing a little bit too much. So we can actually do a value, let's say, or do a random value. So let's see here. We just want to make sure that we cut that off like at 3.2. It's actually, we'll do times, and we'll do 1.5. This way we keep it tied to one of these values. And we'll plug this one into the Z. So no matter how big the twist size, you're always going to be cut off at that point. So that's why I like to use sometimes mathematical equations like this, because it kind of ties it all together. Now, so now that we have this, we want to copy this to the bottom. So we're going to mirror it using, first of all, the area component, right? We're going to get the center point of the box, this box. And now we're going to mirror it, but in the center point, we need to get a mirror plane. So we'll bring in an X, Y plane and plug the centroid into the origin there. And now we'll bring in a mirror component. And we can mirror this object, plug this plane, and last thing we need to do is subtract it. So we'll use this brep that's capped, and we'll do a difference. So I'll go to solid difference and use this brep as A, since that's the one I want to keep, and use both this extrusion into brep B, and holding down shift, you can add those two values. So what I'll do is I'll go here to these two, middle click, disable preview, and as you can see now, the twist is now starting super subtle and ending and increasing in size, and then going back to this. Now, as you can see, it's overhanging way too much, and we can fix that, but just know that this is kind of the way to do it. Now, to fix that, we're actually going to have to go back to this polygon and scale it. We need to change the shape of this and scale it in one dimension. So let me show you how to do that. We'll just scoot all of this over and basically come back to this polygon, and as long as we can change the shape, like we can easily change the shape just by changing the number of polygons, right? But what we want to do is we want to change the shape by scaling this down. So I'll bring in a scale, non-uniform. I'll use this plane as our reference plane, which will be this one. This polygon will be our geometry, and scale Y, X, Y, Z. Well, we'll see here that the green one is going to be X. This is going to be Y. So let's scale it in the X direction, and we'll just say 0.500. When we scale it in the X direction, notice that it scales it down. And that's actually what we want to do. We'll just say 0.5, and we'll use this geometry instead. So let's plug our geometry into the sections, and let's go put this here, clean it up a little bit. This will be twist scale. This is going to be, and here's the thing, this is 1.5 and it's always going to be 1.5. So sometimes I'll take this, I'll delete it, and I'll right click and do data item, and I'll do 1.5. That way we don't have like a slider that I can mess up in the future or something. And I'll take this and disable preview. Now notice that that's way more usable, and we can even decrease the twist to be super subtle, super subtle. So now let's bring it together using union. So we'll go to solid union. We'll use the twist, and we'll bring in the solid form, and we'll flatten the input. Now let's take a look at what we have. We'll take all of this stuff, middle click, disable preview, and let's bake this and take a look. So this is a twist cap, typically like the ones that you would see like on your water bottle or something. And then for, of course, in here, we could just do duplicate face border. Scale this down, extrude it down, cap it, and we can do Boolean difference. So we can also do that parametrically. I just wanted to show you the steps of how to create that form. And on a future video, I'll show you how to create the offset to create the twist cap that's going to go right on top. But for now, this will be a script that I'll share with you on the website. Make sure to check that out. If you have any questions, let me know. If you enjoy the content, make sure to subscribe for future videos. And I hope to see you next time. Hopefully you found this useful.